Hi everyone, welcome to the hands-on dApp training number 2, which is really cool. We're just going to let everyone in yeah, then we'll hand over to Ben again to kick it off. Ben, welcome back. Thank you so much for agreeing to do another workshop for us. I'm sure all the devs and the hackers out there are really appreciative of you being back. So long. I'm going to drop there we go. That's Marigold's Twitter account. Give them a follow. They're really awesome. And they are kind of a part of the Tezos ecosystem. And then give Ben a follow as well if you would like to. He, I'm sure, post super insightful stuff for all the devs out there that want to keep learning about the Tezos technology and ecosystem. A big welcome to anyone from the Tezos ecosystem here. I'm not too sure if Kitty is on the call, but yeah, welcome to everyone. And thank you so much for being here, Ben. One quick thing before I do say anything. Let's actually make it 2 things. Please book a call with me if you haven't already, and we can just chat through kind of your idea of what you're going to build. Always good to get a kind of a time frame and maybe just kind of get a bit of context. It's always good to, I've seen tons of projects now, so it's good just to kind of have a quick chat to me about that. And then the second thing would be the Learn to Earn challenge is still running. There's still a couple spots available for some money to be won there. So please go and do that. It's the best way to learn about Tezos technology and a little bit of hacking and coding going on there. But yeah, that's it. Lovely. Ben, over to you.
Thank you, Jake, and welcome everyone. And I'm happy for being on the second training session here. So just a few introduction. So this second training is following on the training 1. So I hope you have done the training 1 because we are going to take the code from the training 1 and we are going to improve that. If you haven't done the training 1, there is a link on the training 2 for the training 1. You can just take the code there on the folder name solution that you have, or the file here. Maybe you will have to install Prerequisites. That's the only thing. I believe this training will be shorter, a bit shorter, but a bit more complex in understanding some parts. And maybe I will leave like this more time at the end for question. Also, I would like to know what you would like for if you want to have next trainings later, or what you want to understand, because I'm preparing the session 3 on the next week. So what you will learn today is to do some inter-contract calls. So it means that you have a smart contract that is deployed somewhere, and you have another one, and you will do some interaction. So it's asynchronous, so you understand asynchronously, but you have a kind of callback, that kind of simulation that is synchronous. You will discover what is the view or views. You will see that in some cases it's easier to use a view instead of inter-contract call. And also we will see how to do unit testing with LIGO. I think it's good to test your code, and I haven't time in the first session to bring the subject, so it will be time now. Okay, so this is a new POC diagram sequence. If you remember the first training, we had a user. I was poking a smart contract, and we were just recording the traces, the people from the wallet when they were poking. We were just registering who was poking the contract. That's what the fun game. And this time we will write a new function to poke and get a feedback. So when you poke a contract, you will not poke, in fact, directly a contract, but through another contract. So because we want to demonstrate an inter-contract call, so you poke the first contract and you ask for feedback on the second contract. Okay, so you will need to pass parameter here that is P, that is the other contract to poke. So you're poking contract that is poking another contract, and you get a feedback from the second contract, and you store again a trace, but you add also the feedback from the second contract. So it could be a surprise because you will see that you can store whatever you want on your own contract feedback, So you will discover when you're poking someone what it has hidden in the contract. Okay, I hope it's easier. It's easy to understand. So like I said, you take the code you have on the first session. If I show you, is the same. So solution is the same kind of first. The folders are the first is the same as the first session. So you have smart contract folder where you have the smart contract code. You will have a unit test file now, and you have the dApp that is on another folder. So take the code from the first session. And like I said, if you don't have it and you are just joining for the training number 2, you have the link here to get the code from the first session. Okay. Okay, it's what I explained. So about this sequence diagram now, we have 2 smart contracts instead of 1, and we are doing some inter-contract calls now. So we are going to change a bit the code. If you remember, the poke message now would be receiver address, and a feedback would be a string. A poke message is what is passed, what is will be recorded at the end here. Now it's a bit more complex, so I introduce more not only basic I would say variables, but also a structure. So here is a structure. So you can name it as an object if you want. About the storage, we still have the pocket traces, is map of address and pockets. So here is the address of the one that is a user, the address of the user, so this guy. And the poke message is what is returned by the second contract. So is who is sending back the feedback and what is inside of the feedback. Here in our storage of the smart contract, we can store also a feedback string that would be a kind of a static string where we store a value, and we will show it later why we can do that. But we can also hard-code it, the feedback in the response directly. It's possible. So you change the storage, you change what is a poke, a trace. In fact, the trace will be different. The return is the same. That will be used after for the inter-core contract. So the poke function now, so it's big different. So at the beginning, what we will do, we will try to do some unit testing. Okay, so let's start easy. We do suggest some unit testing, and then we will do this interaction. So step by step. So you change the poke function to store this new definition of the storage. So you have, that's why I changed a bit the way that the story is done now. So you have a map now, and you have to understand how to do a copy of an object structure. So to update an object in the storage, so you have store here as an input of type storage, and you have to update only this this attribute. So what you do is you do this called a functional update. So I will open that. It's a kind of copy of an object. I don't know where to do this here. The beginning is here. It's a copy of an object like you see here. So you start by copying the full object, and then the other attributes, they are the attributes that you're going to override. So this is a way to update an object, the full content of an object. So here you said, I want to copy all the fields, if you want, of the store object. And I want to update the attribute that is pocket trace, it is here. And the new value of pocket trace is map add. So it means that I want to add to my map. This is my map. I want to have a new feedback message. Okay, and this returns the full map updated. So if you want to have more information about map, you have a link here to understand what it returns, what it takes in arguments. So I introduce what is called a record or object structure. You have also documentation here. It's you how to build this object and the operation on the subject here. Tezos.self-address. So here, what it means on the library of Tezos, you have self-address. This is the address of the smart contract that is currently running the code. So it's yourself, the address of yourself. And Tezos.source, I think we saw it last time. This is the address of the caller, but at the origin of the call. So you know that you can have a contract calling a contract calling a contract. So if you write sender, it will be the first person that is calling the contract, but maybe it's not the one at the origin of the contract. So if you say source, is a user at the origin of the first call. You see that could be a chaining calls here, chaining calls. Okay, I think there is nothing more than new. So you can, after compile the contract, and then when you have done that, we can. So let me see. I think I haven't touched that. So I think the POC function is here. So that's a new update. You should have updated storage, POC message, new object, and then you are able to write the unit test about that. So we are going to unit test only POC function, and then later we will add new functions, but I'm not going to cover how to unit test the other functions. It takes a lot of time. So let's start with simple unit testing. So what you do, you create a new file in the folder, smart contract folder. Add this command here, and then you copy paste the code, and I will explain a bit more about the unit testing. So you have several ways to do some testing, I would say, in LIGO. There is a unit testing that goes for you doing unit tests. You have the dry run that we use in the first training session. Dry run is kind of a simulation, of a transaction, in fact, to the Tezos node. Here is really unit testing, so you want to test some functions in your of your smart contract. It's a bit different. And I think you have another one. Don't remember the other one. I have to look. So you start to include the source file that you want to test. After that, you can include other things. If you have other libraries, you can include whatever. After that, you have this function here. So you use the test library that is included by default. You don't have to include it. So like you see, you have the Tezos library in the LIGO code. You have this Tezos library that is included by default. In the unit test, you have the test library. So when you do reset state, you start a new state for your blockchain. The first parameter has to be is mandatory and start with 2 because you need at least 2 accounts. It's kind of dummy accounts that will be created when you start your blockchain. So set default to 2. What I do is I take the first one in the list. So this is another function to get an account that has been bootstrapped with the blockchain. I don't explain here the second argument because it means if you want to. So if I look here, no, I don't have that. Is to do some other initialization, but I will take the default one to get the default test, for example, that is necessary for the test. Okay. So I take the first account. I will use it as call my faucet or the baker if you want. To set the baker that will take the transaction, simulate the transaction for the testing framework. The second account, I will use it as my user, sender number one. I have some utility function here, so just to show you that I can display the balance of the user. It's kind of a way like the client as the Tezos client provide kind of same functionalities to get the balance, etc. So using testing framework, you can leverage that too. So you set the baker, you set the source. Source means that will be the person, the user that will address of the user that will call, we do the transaction call. Then you can deploy. So test.originate, it's like the client. You deploy smart contract. Sorry, I want to ignore that. So the first argument is the entry point. So by default is main function. So here in a way, I'm using originate, not originate from file. So there are two functions to originate a smart contract, or you do like me, like this. And in fact, the main, if you do that, it will find, because you have done an include, the variable that is as a function main of your smart contract. You see here, I redo again, is finding it because you have an inclusion here. Okay, the other way is to use originate from file or with file, and you will have to pass a file somewhere, and then you will have to give the name of the function for the entry point to from the file. So it's why it's shorter, because I have done an include. And the second parameter here is the initialization of the storage. So I mean here that I'm passing an object because my storage now is an object. I'm looking here, it's an object now that has two fields. One is a map, what means a string. So I'm passing the first object, and I think that the map is empty. So you look at the library, it says that how to do an empty map is like this. You will have to help the transpiler to understand is the map of what. It's kind of a surcharge of typing to help the transpiler. Otherwise, we give you a warning and tell you that is the map of what. So it's to type for the transpiler. The feedback. So here you write whatever you want. This is the feedback message that will be stored, keep in the storage at the initialization. So you cannot change it later because we don't have a function to update the feedback. So here it's keys by default, but you can write whatever you want later on. You will deploy your own version, then you can play with that and put whatever feedback you want, and it will be hidden on your contract. Hidden, I mean, because you could always read the storage of a contract. And here, well, you don't pay any test. We are in test, so it's 0. It works. This is to get, so it returns this kind of object, the type address and other things that we don't need. So from the type address, you convert to a contract. That's kind of a way to get the contract address at the end. So I will need to do that. Here, yeah. So I need to have the contract address at the end to do some testing. This is the way we do some logging. So you saw that on a smart contract here, there is no way to do some logging. Smart contract, the goal is not to do some logs, and it's not available in LIGO to pollute the node with logs. So you just, I think, technical logs. I haven't found a way to do logs on the smart contract, and I think it's dangerous sometimes because you can write some information on logs or even break some code with logs and bring bugs. So it's possible in the test framework to do some logs. So for debugging, it's great. So I do that like here, let something, whatever, because it's LIGO is like this. If you are like this, you see let underscore. I cannot just remove that part like this. Otherwise, the compiler will complain because we are in the high level of the function. You can do it if you are inside a function like this. You don't need to do let something. But if you are the first level here, you need to declare whatever stupid variable that. Okay, because this is returning type unit or void, and well, you need to do like this. So you do the logs. You can display also the contract content. We have the first function, so I will just keep explaining you how to work the test. So the last part, I always do like this. So this is the initialization part at the beginning. So you prepare the blockchain, then you deploy a contract, then you start writing some utility functions that will be reused to do different way of testing. So by this, I mean that these are your test cases. So I will have this one, etc., number 2, number 3, etc., etc., etc. And then here I can change, parameters, having different parameters, 1, 2, 3. Like this, I will reuse the same function, but in a different configuration with different parameters. It avoids me to have to rewrite several times something. So when your function starts by test, it means that it will be on the, so here, I did it just before. So if I just say, I think I didn't change anything. Anyway, okay. So if you look at the logs, at the end, you will have the resume, summary of your test, and you will have only the function started by test that will give you a return value of Boolean. Okay, so this one will be taken because start by test. Okay, it's just a convention. And every function that you have here, any function that you have here, not starting by test. So for example, if you put the underscore here, would be kind of a utility function, but will not be part of the end scenario. So if you see here, it's just a variable of the function definition. And here is where really I call it with the arguments, and will be part of my summary of the test. Okay. You see before that, I have some logs. The logs and I have all around during the initialization. So I start with that. I see my balance. After I display contract something, that's the address of the contract. And then I run something. So here, if you see, I do this function here. I'm setting. So there is a status here. So transfer to contract is a way to call a transaction. That's the transaction call in the unit testing framework. So you need to pass the contract, not the address, but the contract. So here. And then you pack the parameter is my entry point function. So it's poke that we saw before, at the entry point here on my function. So I want to call poke, so you remember the first training with 0 test. And then I'm displaying the status, so it's status success. So the transaction succeed. Now what I do, I can take the storage and have a look on the storage of the contract, so I can display what happened. And if I look at what happened, I have, so this is what I set on the initialization. And on the pocket traces, I get this new message. So there is no feedback because we have not used yet the inter contract calls. So if you remember the sequence, we are not yet done this part. So it's just a poke, simple poke. So we don't have feedback. We just remember the address of the contract. So if you remember, it was self, I think, if I remember, and self itself. So we just take the guy who called that random user that is done by the testing framework. So the random address of the user. And we register the trace with who gave you the trace. So it's a contract itself because it's run at the moment. Let me have a look on the chat. Maybe there are some questions already. The meaning of the 3 dots. Yes. So I explain it here. It's a copy. So the first argument is objects that you want to copy. I think in JavaScript you have the same in basic JavaScript, and in other language you can do some copy of it's object copy, reader copy. It's not a reference copy like you can have on other languages. Not the reference of the object; it's really a copy field by field. So it's a new object. Okay, it's a new object but with the same values. So it's just to say that you want to copy the full object, and then after you override field by field or attributes by attributes with new values. Can you test in normal JavaScript versus JSLU? Can you test in normal JavaScript? No, because you will need to import. So I don't know if you have a way to import the test library, but everything is based on the test library. Also, using the LIGO command here, run test. Run test is expecting a JS LIGO, not a JS LIGO, a LIGO, whatever languages you have, file. So it works with any LIGO message. Any will import the libraries. I don't think it's feasible if you do pure JavaScript, or maybe if you play with the package, npm package, and you import maybe, but it will be a bit difficult. The libraries of LIGO to because you need to, if I do like this, there are a lot of there are a lot of functions I need from the testing library. Create a state, the logs, get an account from the state, originate a contract, some utilities, there are kind of utilities function here, and to do a transaction. So I will ask this question. I will take some notes here, but I don't think you can do it in pure JavaScript really. Also, if you include the library in JS LIGO, I don't know if it works. If you do a reference like this to a variable, mixing languages, I'm not very comfortable. I don't think it's even feasible. Okay, what is underscore? Yeah, the underscore, like I said, is if you have done Go language, if you program with Go, you have exactly the same syntax in Go. It means that the underscore, you don't care whatever variable it is whatever variable, but you are not going to use it later. You could name it, whatever 0, whatever 1, whatever 3, whatever 4. But if you don't really use it, it's so just let the underscore. If you redeclare 2 times the same variable, the compiler will complain you're not able to compile anymore. So it's a way to do this. I don't know why. I don't have the reason why we cannot do this like this on the root, on the code. I don't have the reason. I can ask the LIGO team why. But if you don't do that, it will complain. So if you see, if you are inside of function, there's no problem of that. I will ask the reason. I think it's something maybe relative to the transpiler to have some variables everywhere. It can be on the root level. Because it's functional programming, so functional programming, they don't like you have instruction like this. Everything is inside of something. I know. Not making sense. Okay. I think the score is a placeholder variable. Yeah, is variable to say you don't care about what is returned, but you need to declare it because of the compiler. Okay, I think I have seen all the functions. If you have a question about the unit test, I don't know where you are in the copy paste. I haven't explained everything. So I was explaining about getting storage and the logs. So we are good with that. Well, if you do unit testing, you do assertions. It sounds a bit obvious if you have done unit testing. So what you do here with the batch, you are going to look at inside of the pocket trace. So in a map, you want to, so S, remember S is parameter of the address. So you want to see if your map pocket trace has a user S. S is the source. So it's a user sender one. Okay. So the way to do that is to use map dot find option. OPT is for option. I will answer after. So you don't have the find because sometimes if you search for something, sometimes you don't have the result. So that's why the team give you the function find option. So it will return you an optional. So if you are what you don't know what is an optional, it means that either it contains a value, either is a new value, and it's encapsulated inside a response object. It's not to deal with new. Sometimes you can have some trouble with some languages and you don't use optional and you don't know what is new, what is double quote for a string because it's string empty, or in JavaScript what is undefined, and it could be a mess. So here we have options. So you look if your user is inside this map. So the match I remember for you is a kind of a switch case. So you have either some it means that you found it. So the user is part of the map and it will return you the object. So it will return you the value. So the key is the user and the value, if you remember, is the trace. So it will give you the trace that it has registered. And if you don't find it, you return false. So false, so every function that you have here should return a Boolean. So it means that your test is failing. And that's why here you have your test exited with a value of. So if you don't find the user, you have a problem because the assertion expect you to be the key of the user. So you have to be the address of the one that did the transaction. So, and if it's okay, then you look and you do another assertion here. You look on the feedback. So you look if the message contains feedback. The feedback is an empty string because, like I said, we are in the not yet doing inter contract call. So feedback for the moment is nothing because not coming from another contract. So you look if the feedback is an empty string. So you look here and it's true because we display the storage. And you look what here. empty. That the error message after. Okay. So first is a condition. So you test the condition, and then if the condition is not realized, then what you do is to display an error message. So if I cheat like this, for example, this. So I break my unit test. I think I can do that. So I should see it here. So here you see that I still have the logs that are correct, but at the end my test is failing and I have an error here. It's not with the assert. Okay. So I'm cheating here, but just to show that you have display of the assertion failed somewhere. And also you test second that the receiver, it should be, like we said, the receiver should be equal to the contract address itself. So it's Tezos step address. And if not, you have this assertion message error that is displayed on the logs. Okay. And okay, you return true. Don't forget, because you have to return a boolean. That's what you see here. So like this, you have only one function here, but you can write several ones, and then you will have here a list of all the unit tests that you have launched. I haven't found a way yet. I don't think it's available to have the sum, but you can do kind of a simulation, because I like to have all the tests like this, with the naming. So testing, sender warbox, something, testing failed, something, testing like this. I have a list of everything, but after at the end the logs, I have true, false, true, false, but doesn't give me the sum, of the and to know if all the tests pass or not. I don't know if all the I have to look line by line if everything is true, and I haven't found a way to still to concatenate everything to say, oh, my test batch has passed. I don't think it's available for now. Okay, take questions. Why do you set your faucet address as baker? Because I need we have two accounts that we need to create for the network, and so I take normally the first one. You could call it faucet or whatever, or baker. It doesn't change anything, the name. Just the first one, I take it to be a baker, and the second one, I want it to be separated for my test, just to simulate a normal user. So you can put whatever name here, doesn't change anything. Just want to have two accounts. One would be baking, and the other one would be the sender of the transaction. And like I said, you can create several ones, a lot of accounts. There are other functions also in the test framework. Does really baking? Yes. Yes, it's kind of simulation of baking. Yeah. So also you can have some problem of errors if it's not ready to bake or whatever. You have some errors in the test framework. So it's a simulation of baking, really. Yeah. So what I was saying also, there is other function you can have here. You can also bring your own account, kind of creating your account not from here, but I mean outside. You can create an implicit account from the test framework, and then you bring into the state. Say, okay, I want to create my account giving a private key, having a specific hash that I want because I need it for doing something. Then you can create your implicit account and then bring it to the state. It's a bit more complex, so it's really that you need to have the private key and the public key, for example, for doing some signature check or whatever is possible. But by default, I recommend you just to do that and take the address, and it's okay with just public address. You can do normally whatever you want for basic texting. Okay. So we will start. I expect that you have done the unit testing. We will start to have the inter-contract calls. So now we will have this sequence of calling another contract. Okay, that is a bit complex part. The more complex part. Okay. So what we do, we need to have a new function. So I don't want to break the poke function. Let's write a new one, poke and get feedback. So you come back to your source file here for the code. And yeah, we leave the poke, like we have the unit testing. It's okay. You can play with that. And we will write another one, poke get feedback. So it's a new parameter. So you have on the main here, you will have a new entry. Okay, poke and get feedback. So it will be the function that is here. It will be called by user, poke and get feedback. Step 3. And this function will be cut into, in fact. So because you will have one part that is on your main contract and one other part that will be in the other contract. So what you have to do, you cannot do that in only one function. So the first part of the function is here. And the second part of the function will be here. So because it's asynchronous, you will start here. Okay, you start here, you call the function. The function will do kind of async code here, and we terminate. And then this function will execute what it has to do, and we call the callback, and we call another entry point here to continue the second part of this function if you want, and to terminate it for updating the storage, for example. Here we need to update the storage with the feedback that is coming from here. And because we cannot do that in a normal way, I would say, with async wait that you can do in JavaScript or whatever, because you do a transaction and after you have to stop and let the second contract call you back later, maybe with being on another block, you don't know. It's not on the same computer. We have to cut this function in 2 parts. Okay, that's the complex part here to understand. So the first part is name poke and get feedback, and the second part is the same name but you add callback at the end. So it's the 2 parts. And the function that is on the other contract, we will call it get feedback. So it's a function that is here on the second contract. We call it get feedback. Okay, just a note here. You will see a lot of time. So inter-contract calls. Why you have to do that? Well, here is to introduce that because there are a lot of smart contracts. They are calling oracles, what is called an oracle. So I discussed about that last time. I said to you that if you need to have some data that is not inside of the smart contract, instead that it's sandboxed, like calling an API to get currency pair rates, for example. Well, you cannot do that inside of a smart contract. It's not possible to do a call from the smart contract to the outside world. So what you do, you use an intermediary smart contract that is named an oracle, for example. And this oracle, the goal is to receive data that is pushed from the outside to update its storage. Okay, so there is a very famous one in Tezos. It is named Hotbinger. You see, it's giving you the currency pair of well, you know, the main currencies you have, cryptocurrency you have. So this is a website, but this Hotbinger, you have the project here. is taking this information from the internet. So different, I think, DEX. I don't know where. Yeah, okay, like you see here. So information from Coinbase, Binance, etc. So it's aggregating all this data. You have to trust it, because it's not on the blockchain, it's somewhere running on the web. Is taking all this data and is pushing it inside of the Oracle. So it's something that you have here and is pushing all this data inside of this Oracle. So this data is available on the storage. And so because this data is available on storage, it's available for everyone that is on the Tezos network. So a smart contract can call a transaction function here to get, for example, the price or whatever, or get the feedback like we have in this example. Okay, so it's very common to do that for oracles, but you have other contracts that need to be, the application is so complex that you need to interact with other contracts. It can happen. So maybe it's not just a pure oracle, but it's just another smart contract that you need to interact with. Get updates. Okay. So it's just to tell you about that. Just give you the name about Oracle. So we will consider our second contract P as an Oracle. So what you have to do, let me show you. You will have to first change the parameter to add a string new function. So I cheat a bit here. Well, in normally you should have to write a new contract, okay, a new file with new contract. So you have two files, but it would be a bit maybe too complex to write two files to do some inclusion everywhere, etc. So I will cheat a bit, and I will deploy. I will write the code of the second contract in my first contract, and I will deploy 2 times the same contract. Okay, just to go faster. So what I will do, the get feedback function here, I will take it and I will write it in the code of the first one, and I will deploy 2 times the same contract. I click, I will simulate contract to another contract, but it's myself. So what I do here, I add the 2 parts of the function I tell you. For can get feedback, for can get feedback callback at the entry point for my main smart contract. And here get feedback, I should write another contract for that, but I will write it here in the same function to go faster. I update the main also to tell what entry point points to which function. Okay, so I will get the same name. I will not change functions. And I will need to pass some parameter. So the parameter of this function here is the address of the second contract. So other is the other contract address. Because like you saw before, I will need to call here and I need to know the address of the second contract to get the feedback. It's logic. And here for the get feedback is a callback, contract callback of type Oracle param. And here what I need to pass is a contract that call me with some information. So that's mandatory. Here I need to have a contract object here. So why? Because when I'm here and I'm receiving a call from somewhere, I need to have the callback. So I need to have the contract that call me as a parameter. It will be injected as a parameter. And in this contract, I need to give different information. I need to know the address, and I will give in return something, an object that in my case is a string that is feedback. If you come back here, this is the address of the contract that calling me, and this is the feedback that will answer back. And the last function is to write the second part of POC and get feedback. So what I will receive here is what is pushing me, what this guy is pushing me. The second contract is pushing me. It will pass me as parameter to my second part of the function here. So I have Oracle param, and I will, sorry, here. I have return feedback, and I will take the feedback and do something with it. Okay. Okay, to start to write get feedback is quite easy. So on the Oracle side, get feedback, you need to have a contract of something. That's mandatory. And so I pass a storage, so you can add a storage if you want to update something, because you need to have a return of something. It's always you need to return a list of operation store. So you add a storage and return. You don't touch the store. What you do in the get feedback, you are going to prepare a transaction to call the first contract. So we are in the Oracle code here. So we said Tezos.transaction, you pass the parameter. So as the first parameter, if you remember a pocket trace is a pair. The first part is the address of who is giving the feedback, and the second part is the feedback. So what I said is me, the Oracle, and this is my feedback. This is the parameter to give the Tez, so 0. We don't need to pay something. And this is the destination of the transaction. So this is the contract. The contract that we need to call. And as it is passed on parameter, I just say, okay, you configure me with that, you call me, and then I call you back, okay? And then you submit the operation here on the list. So the store, you see, you don't touch it, you just read the feedback. But here you need to pass an operation to say, I want to do this transaction. Okay, a little word about this pair here. So why you cannot do like this? You see here, so you have a pair of parameter in the definition, and why to not do like this? Like you have in JavaScript, for example. Well, it is like this. If you have more than one parameter, you need to wrap in a in tuple or pair of parameters. So you have to transform this classical definition of my param of type my param2 of type 2 into param1 param2 of type param1 type param2 type. That's the only way to make the things work. I asked the team of LIGO why it cannot be possible to do that, but for the moment it is not possible. So I hope in the future it will be easier to do like a JavaScript way of passing parameters in the function. Okay, so this I explained it already, how to pass the transaction and returning the list of operation. Okay, so this is how to write the part of the get feedback that is on the Oracle side. And now let me check if you have questions. Is there a way to take a Michelson smart contract and convert it into LIGO? Oh, well, maybe the transpilation, the reverse transpilation is feasible. That's a good question. I think it's feasible, but what you can get could be a bit weird because you don't have is everything simplified in my custom, so you don't have variable names, etc. So it will be, I think the variable name will be auto-generated or whatever. It will not be very easy to understand the reverse engineering, but maybe it's feasible. It's a question I would ask to the LIGO team. The reverse transpilation. Well, if you do that, I suggest that you want to do retro engineering of what is of a smart contract that is deployed, and you don't have the source code. I think it's readable, but readable, quite hard. Okay, so let's write the first part of the function poke and get feedback. So what we need the address of the smart contract of the Oracle and the store, of course, because we need to return it anyway. So what you do here, you need to take the contract from the address of the Oracle address. So here is a type of address. What you need to have is a type contract. So what you would do, so you see here that the definition here is a contract of Oracle param. So I need to call this function here that from an address, and here even more than the address, I want to take the entry point that is named get feedback on this contract address. And if I do like this, I will get back a contract option, an option of a contract. So here you see, it's an option of a contract of this parameter. So like before, we do a switch on the optional. We look if there is known, so I don't find this entry point that is a function in this Oracle address, and I fail, of course, because it should exist. If I find one, it means that this is the one that is found. So I have the contract, and what I do, I return the contract. So I return the contract in my variable, and I will use it after for the next operation. So what I want to do is a transaction. So in the sequence, I want to do a transaction. So I'm here, and I want to do this transaction. Okay, that's the transaction I want to do. So I have the transaction here. I need to pass my first parameter, the test, so 0, and the destination. So I just get it from before, destination of my Oracle, from my Oracle address. And the parameters here, if you remember the parameters, they have to be an address of a contract. Has to be an address of a contract because it's mandatory. Okay. And this address of a contract is in fact myself, and even more than myself. So if I do Tezos.self, I just have the address of myself. But what I want is not only the address of myself, I want to redirect to one of my entry points. And this is the one I want. This is the second part of my contract. So I said to the Oracle as a parameter, when you will use the first parameter that is an address to call back, please call my entry point that is named like this. Okay. So here I'm calling the Oracle address, and I'm passing as a parameter my entry point here to call for the callback. Do you need to write 0? This parameter is mandatory, so yes, you need to pass something. So 0 because it's free. So you have to understand that it's very important to understand that you are in a blockchain that has a currency that is inside of the network itself. So for example, if you have to pay for calling the function, this is the way. So if you say you can call my function, but you have to pay 1 Tez to call my function, this is kind of monetary or economic stuff to do the thing. So if you pass 0, it means that you expect that is free. The code to the other one, just pay the gas. That just means that for the baker to execute your transaction. But I mean that the owner of the smart contract you're calling is giving you to call his function for free. Okay. If a function requires to pay something, for example, you're asking you, it will cost you 1 Tez to call this function, then this is the way when you pass the parameter here to say, okay, I know that calling this function, I will have to pay 1 Tez. So if I put 0 here, I need to have 1 here, okay? I need to pass at least 1 here. Otherwise, I'm pretty sure that my transaction will fail, okay? And this, you will see it when you will call at the beginning. You need to pay it from somewhere, okay? These tests, they are coming from somewhere. So it's the one that is doing the transaction that is paying this amount of money. Here in this case, it's a contract to a contract call. So it means that the test is coming from the balance of the first contract. So if I take this example here, from here to here, if I do a transaction and this guy is saying, okay, my function needs to pay 1 Tez. So it means that this guy has to pay 1 Tez. So it means that if it's not the smart contract that has to pay, but the user, it means that here also you can have a way to say, okay, if you're a user and I know I will have to call this guy, will cost me 1 Tez, maybe I will tell the user also to pay 1 Tez like this. User pay 1 Tez, I take this Tez and I pay the second contract. Mutez versus Tez. Yes, there is a conversion. Normally, everything that is passing through, you have 2 ways of managing money, is Tez or Mutez. Just this one is a smaller unit that you have. Okay. So by default, I use Mutez because it's the smallest one. But you can say I want to have 1 as Tez, for example. But it's the same as 0 Mutez or 1 0 Mutez or 0 Tez. It's the same. It's just representation of the decimal, if you want. So if you look at, it's 1 million difference versus Tez. Smallest monetary unit. It's like the Satoshi versus the Bitcoin. See, it's 1 million difference. 1 Tez is 1 million micro Tez. So it's same money, it's just different way of representing it. Most of the time, in the smart contract, we manipulate Mutez because in LIGO, or I think it's going for Microsoft, in fact, there is no representation of floats, okay, of decimal. So if you want to do some operations with Tez and you have some decimals that appears, you will have some troubles to represent that because you have only int and nat. So they are integer or positive or negative, depends on what you're doing, but they are integers, they are not floats. They are manipulated by the system. So that's why I do all of my operations with my component Mutez. Like this, I only have nat and int, and I can do whatever operation I want. If you manipulate Tez, you can have some troubles if you have floats. Of course, in the UI side, when you receive information within Mutez, then you display differently with a float. That's no problem. But you should be on the client side. Presentation with floats. Okay, so I was saying about the feedback. Okay, get feedback. That's the first part of the function. Then here you call the oracle. Is a call to the oracle and you give the way to have the callback function if you want. And then you have to write the last part, that is part 2. of the first contract, and this is the callback function. So here you receive the answer, the transaction, in fact, from the oracle that you receive here. You remember the types. It's divided in two parts. It's a pair. First part is the address of the oracle itself that he's giving you, and the second part is the feedback that he has in his storage that you have done in the initialization. So it's what we call a feedback message. It is a trace that we want to store. So what you have to do, if you remember the flow, you just have to store, in fact, what you receive from the oracle. So this stuff operation, there is nothing to do, no transaction to execute, just to update the storage. So if you remember, you copy the store because it's an object, so you copy by value, and then you update the pocket trace, and you just add to your map, you add. So if you remember, the first is a key, that is the user, if I remember. And the second one is a feedback message that contains the oracle address and the feedback. Then you can compile it, and if you want to do the unit test, it's a bit complicated, but it's possible. If you have time later, just do unit test of this. It should compile correctly. Okay. Do you have any question on this scenario of calling contracts, other contract, calling contracts, and it's quite, I think, it's quite normal in the ecosystem. Tezos contract try to call the contracts, a lot of interactions. Also, I mean that your contract is a standalone contract and just work by itself. Also, is possible. What I do, two application I have done is they are standalone, but there are a lot of contracts need to have interaction to other contracts to do some operations, like in the finance contracts, financial contracts. Well, I have an example using an oracle, so it's true I am calling another contract. Okay, is it clear for contracts or in other contracts? Yeah. So I can talk about views now. Okay, so it's a different way of doing things. So views. So why we will rewrite this? We had a pain to do this. It was a bit complex. Why we will rewrite that? It will be easier to do it with views. So what are views? Views is a way to read the storage of another contract without passing through a transaction. So if you pass a transaction, you have to pay fees, even if I think when you call contract to contract, you don't have fees maybe internally, but it will cost a lot of time because you have to pass this on the block, etc. And well, it costs you money, I think, and time. So there is a way to have a kind of read-only of what is stored on the contract. So you can do that today with a RPC node. You can read the storage of a smart contract and get the storage, or use an indexer to read the storage of a smart contract. So you can do this kind of introspection. But from inside of a smart contract instead that is executing, how you can do that? So it's what is called view, on-chain views. So it is to expose all your full storage or part of your storage to other smart contracts. Okay. So you will see that the code is much more simpler. So what you have to do first, it will not cut your function in two. That's the good news. You will have only one function, or can get feedback, but not the callback, because you're not doing some async callback stuff. So that's good. It simplifies quite a lot. So instead of preparing the transaction call, no, it's free. No, Does any transaction fees apply when requesting a view? No, it's free. It's just a read of a storage. That's I'm pretty sure it's free. So instead of doing a transaction call, what you will do, you say call view. Call view, you will give the name of the view that is declared with annotation. We will just see it a line later. So give you the name of the annotation that you want to read. It's a variable. This you can pass some parameters, it's possible. Well, in my case, I don't pass any parameter, so I just pass type unit. And you need to pass the address of, well, in my case, it's an Oracle address. So I say this is still my Oracle address. So it's the same I used before. This is my Oracle address. So I have to declare now in my Oracle address a view that is named feedback to get back the feedback. And it will return an optional again, because well, if this view does not exist, or maybe your contract doesn't, or whatever happened, fail, well, you have a known here, a failure. So it could fail. So that's why you have an optional. So you expect to have this optional here, and then you match again. So if you don't have anything, then you fail. You can get either the Oracle address or the feedback view or whatever happens. It's a failure. You fail. If everything is okay, you get a feedback from the view, and then what you do the same thing that before. Is exactly the same code. You prepare the feedback message and you store it. That's the same code that before. Okay. So you see that the size of the code is really shorter. And well, you can read it easily than having all these come back, passing all these parameters for kind of type, etc. So it's easier to understand. And the declaration of the view. So if you go on the Oracle side, it's even easier. You have just to declare a variable with an annotation. This is a way in JS Lego to do an annotation. So you do just a comment and add view. It's an annotation to say that my here is a view. So it's for the transpiler. So this feedback will be part of the views of the contract. This is mandatory. So you need to pass some parameter. This is a parameter that they used before here. Or in my case, I don't care. Like I said, just said is of type unit, and I don't need to pass anything from the color. So I don't care the first parameter. And the second parameter is the store of my Oracle here, in fact, capacity, because I will use it just before, just after, sorry. And it's returning a string because my feedback is a string. And what I return is store.feedback. Easy. Is a feedback at the initialization of my Oracle that I set to something that was keys, if you remember in my test. And then you compile it, and you can write the unit test too. Okay, do you have any question on the views? I think it's pretty simple to use it. So you use a view in a case that you just want to read. It's a read-only stuff. It's not completely true in a way that, yes, it's a read because you want to have a return of something normally. But you can even do something. If you pass, for example, here a parameter to say, okay, or you have to do something here, you still have a way when this will be executed. Okay, this function on the Oracle will be executed. So if you pass or you don't pass, don't change anything, but you can say, okay, I will pass something here to say you have to do something. You can even change the storage, I think, or not. You can change the storage or not. No, not even sure. Oh yeah, maybe. No, because you return a string. No, I'm not even sure of that. You cannot change the storage. I think it's a read-only operation, but passing parameter, what you can change is doing some switch and change the response. No, I would search on that, but I think what you have is a read-only. because here what you have to return an object, so you cannot change the store of the oracle. You pay when you return something? I don't think so. I think it's free when you call and when it's returned. I think it's free. It's an internal call. I think. I would check that. I would check that because maybe I tell you something wrong, but I haven't seen, because it's internal call and it's not passing through transaction. I haven't seen fees personally. I don't think they are hidden, but is there any fees on that? I don't think so. Okay, so pretty simple. To replace your code, I can show you very quickly what I have done. What you have to do, of course, is to don't lose this. You have to comment all the parts that is the callback side. So this you comment the callback second part of the function. This you comment the get feedback on the oracle, because now you have to declare a view. So comment this, comment the function also here and here. Comment the parameters, because you have only one function. It's easier now to call, only one. It is exposed to the user. And that's pretty much what you have done. So normally you have changed this function here. It should look like me, calling the view, and after unwrapping the option to just update the storage. So this code is pretty simple compared to before, that you have 3 functions instead of 1. Okay, I don't do the unit test. You can try to do it. Okay, now let's pass to the dApp. So this is a full application with the client side. So what you can do is to take the solution from the first session, if you remember, or you can copy. That's okay. So you go to the other side. Okay, and what you need to do first is to redeploy a new smart contract because you have changed the code. So it's not the same one. So you will have to, not yet here, but here. You can compile the contract here. You compile the storage, that will be the initialization. So here you have the initialization of the storage as a parameter. And then you take the Tezos client, like in the training one, you originate a new contract. So if you called before the alias my contract in the first training, you have to add this force to override the alias of your contract that you already deployed. So if it is your first time, you don't have to pass this force parameter. And from your account name, that was your account name from the first training. So where you get this is from the faucet. This is Michelson that you have transpiled. And this is the storage that you also have transpiled from the second line. So that's pretty much the same that you did in the first training. So I hope you are connected to Ithaca. I will deploy to Ithaca network. And don't forget to get the address of the contract you deploy, because you will use it just after. Okay. Okay, when you have deployed a new version of your contract, now you can pass to the app application, the React app application. So you switch to the React application here, and you will need to update few things. First of all, you will need to update the contract address. So you look for this here. You look on the file, it was here, and then you update it with contract that you just deployed. Okay, so you point to the good one now. After you will need to declare the new type, okay? Because you change the storage, so you copy paste from the contract, a new type. It will be the POC message because we will display it. What you need to do, the contract to POC. So the contract to POC will be the parameter of a contract you want to POC. So in the sequence, with the Oracle, we will try to POC this guy and get a feedback. It's the same. You POC and you get a feedback. Okay, it's true that I haven't written here, but you POC, you read, and you POC and get a feedback. So you need to pass the address of the second smart contract. So you pass it as you declare it here, and it will be an input text on your application. There will be an input text here. So you take it on the form with an input text on the form, and you write new function. So you had a function POC. So you need to update the function POC that you had before. So you look, it was this function, so you update it. Now he has is passing a form. So here just to avoid the refresh of the page because you will submit an input to POC now because you're POCing to a contract. So you need to pass a contract address. This is the same as before. Here you pass the new name of the function. Before it was, remember, default because it was the unique function. Now we have two functions. So this is the name of the new function to call on your contract. This is entry point, POC, and get feedback. Don't forget to always put a lowercase here. And you need to pass the input parameters, the address of the contract to POC. And this is pretty much the same. What you need to change at the end is just the HTML template here, just to display a bit better. So what you did display is the pocket trace, but the pocket trace now they have changed a bit. It's not just a simple address. Is you see here is a receiver plus a feedback is an object now plus the key that is the user that at the origin of the POC trace. Plus you need to have a button POC like before, but you have to pass a parameter that is an input text. Okay, that we display. Okay, enter the contact address here, what you will take, and you bind it. So if I look on that, the form on submit, input text on change is here, console.log if you want, but here you bind it here. So every time you change your input, you will get the value of the input text. You will set it on the React. Okay, what it looks like. So let's go back to the app. Okay, let's see. Whoop. Okay, so if you remember, we did in the first training how to connect to your wallet. So I'm connecting with my Temple wallet. Sorry, it's switching my mouth. Okay, I'm connecting now. And we will use the same code, fetch contract. So we just change the contract address before. Okay, I see someone has deployed good a contract. I see here. So it's two contracts I deployed myself before. So what I'm displaying now is by line the contract that has been booked the feedback and the user. So this contract embrace is user, this contract kiss this guy. It means that this contract hold the feedback that is kiss, and I know this contract hold feedback that is embrace. So you remember by default on the is kiss, but for example, I'm connected with this guy. I will try to poke this guy. So what I'm doing is I will take this one. So this one is doing a kiss apparently. And this one, I don't know. So let's use this contract. I will use this contract and I will try to, from this contract, I will try to poke this second contract, okay? Let's see. Okay. I'll inspect maybe to have the information. Oh, transaction done. I put an alert. I put an alert, so it's okay. Transaction done apparently. So apparently this guy is kissing. So from this contract, that's my first contract. So here I'm calling this first contract. I try to poke this contract that is here and it's answering me, kiss to me. And this is, I'm the connected user. So apparently, I don't know who deployed that, but he had a kiss feedback. Okay, so I'll let you time a bit to play. Let's refresh. Maybe other people have deployed. So here, this contract here is a storage. Is a storage of this contract that I'm displaying here. So you see that the storage here, it has two lines on the map. So if you remember, it's a map. It's a map of the first is a key that is the user, and after is a value that is a contract with a feedback. Is the pair contract feedback here, and this is the key of the map that is the user who did the action. So I did an action here, did an action here. I don't know who did an action to this contract. Another guy. Let's refresh. Okay. Let's go back here. Okay, so when you have updated the HTML, then you will launch the app like I did. And you have this table with all the people who deployed a contract that is similar to mine. So you should have the same entry point. Means similar, it means same entry point definition, same storage definition. Just mean that. So if you just respect the same definition of and copy paste, your contract should appear on the list here, and then you can interact with this contract to poke another contract that you have here on the action, and then to see the feedback of the other contract that you are passing parameter. Okay. Do you have some question on the React side? How we have updated? So there are not a lot of things to change. Just to resume, more or less you change with a new contract that is deployed, the new version. And after just a bit of React, just to have a form to for the button and the display a bit. And here we change a function that is now poke and get feedback. It's a new entry point we have added. Okay, so we have finished this training 2. For next time, I'm thinking of explaining how to object a contract, a smart contract that is deployed, because you are in blockchain. So when you deploy a smart contract that is immutable forever. So I will dig into that, I think, for the next time. And also the usage of tickets, because something that is quite used, in fact. So explain tickets next time. Okay, Jake, if we have the question time now, if people they want to ask question about this training number 2.
Perfect. Yeah, we'll stay on the call for another 10 minutes or how long it takes. If you have questions, please feel free to ask them in the chat. If you don't, I'm sure you can also head off. I'll just say a quick thank you so much, Ben. We really appreciate you being here again. And hopefully, yeah, we can get another workshop in during the hackathon. But if you have any questions, please shoot away. You can ask in person or you can just ask in the chat. I'm sure Ben will appreciate it.
Okay, question about who did embrace? It is not. Okay, like I look here. This guy is kissing. This guy is kissing. So I suppose that is this guy that is embracing. So if I continue here and I poke here, let's see, asking me to unlock my wallet. Okay, submitting operation. Let's wait. So I have a pop-up alert now. It's better like this, I know. Embrace. So yeah, is this smart contract here that has in the storage, when you deploy the contract, you say my feedback, store.feedback, the value is embrace. So when I use this contract and I try to poke through this contract, this guy, whatever I did here, this guy has embrace feedback. This guy, we saw it, he has a kiss. So you can look like here, he has a kiss, and this guy also has a kiss, if I remember. I can try to do like this. Hop. I'm playing with it. You will see normally it has a kiss, I saw it before. Yeah, each contract can only store one feedback parameter. Yeah, if what I designed this training number 2, you can have whatever you want. It's just a use case that I want to have one value in my feedback. You can have a random string if you want to answer different things. You can store whatever you want. You can declare different views. You can do whatever you want. Just an example. Not yet done. Oh, okay. I don't have the alert, but it's done. So he's kissing. It's just a stupid example to say that you want to have an information that is stored in another contract. You use a view to read that without passing through inter-contract calls that do a real transaction, then takes more time, etc. Maybe some fees. I have to check that it's taking fees.
Okay, cool. I think we'll call it there then, Ben. Thank you so much to kind of the Tezos ecosystem and obviously to Marigold for being here and giving a fantastic workshop. Hopefully you'll be able to get one more workshop, and I know the hackers really appreciate getting some quality technical teaching. Yeah, so the more technical workshops, the better. And hopefully the better submissions in the projects that we get. So thank you so much. We really appreciate it. Encode appreciates it. And thanks to all the hackers that are here. We will keep chatting on Discord, keep booking calls with me, and hopefully we'll see you next week for another workshop.
Maybe, yeah. Good. Yeah, I hope it will really help you for the hackathon. And there are much more things to tell, but yeah, you need other sessions.
Perfect. Thank you so much. Perfect. Cheers, everyone.
Thank you, everyone.
Yeah, bye.
Bye-bye.